So, what do we know about the area of a rectangle? Yeah. So, if I know that the area of a rectangle is length times width, that is going to help me set up and solve an equation for the dimensions of my rectangle. All right, so do you guys want the book to go up and down or sideways? I don't care. Sideways? Yeah. Okay, so we know that the short side is the width, right? So if I told you that the width was 8, for example, what would the length be? 5 more than 8 is 13. So once we find the width, we can find the length by adding 5, right? No big deal. Okay, so let's call this little baby short side the width. We don't know what it is yet. Now, is my long side going to be 5 times my width or my width plus 5? If it's 5 more. Is it 5 times more or just 5 more?
5 times.
Just 5 more, okay? So it's not 5W, it's W plus 5. Does everybody understand why? It's not 5 times longer than the width, it's just 5 more. So when I told you 8 for the width, you added 5 to get 13. You didn't multiply the 8 by 5. Okay, so draw and label a picture for a rectangular book. Check. Now they're telling us that the area of the book is 36 inches squared. And we have to write an equation to represent the area of the book. So we're going to use this little equation. You already told me that we know what the area of a rectangle is. We're going to use that. Area equals, I'm going to write the W first, but you realize the order doesn't matter when I'm multiplying. Isn't 2 times 5 the same as 5 times 2? They're both 10. So I'm going to write W times L just because I'm cool like that. So what is the area of my book? Yeah. So I'm going to take that and I'm going to substitute it in for the A. So that is a 36. From my picture, isn't my W just W? Yeah. And my length is this W plus 5, right? So I'm going to plug that whole thing in for my length. Okay, so I just plugged in the 36 for the area, and for the L, I put in W plus 5. Now I have an equation that I can rearrange and solve using my quadratic tricks to find my W. So let's do that. We wrote an equation already. Check. All right, now we're going to solve it. So most of my tricks require that one side of my equation is equal to what? 0. And that my equation is in standard form. So ax squared plus bx plus c. So I'm going to get everything over there, and I'm going to rearrange this w stuff by distributing my w. I'm going to multiply them together. So that gives me w squared plus 5w. If I subtract away the 36 from both sides, isn't it going to be negative over on the right? So now I'll have a minus 36, and that will all be equal to 0. Is everybody okay with what I just did there? Okay, perfect. Now, doesn't that look like something I've got a hope of factoring? Okay, let's try it. Let's see if we can find some magic numbers. So we're going to multiply to negative 36, and we're going to add up to 5. Oh my goodness. First I made my line too big, then I made it too small. So adding up to 5. So 1 times 36 is 36. 2 times 18. 3 times 12. 4 times 9. 6 times 6. Yeah, the 4 and the 9. Which one gets negative? Oh, the 4, because I still want a positive 5. Do you guys see why? Okay, so it's those two. So I'll have 0 equals my W minus 4 times my W plus 9. So far, so good. I have to figure out what the W's are. What are they? Well, I need my ZPP. So I'm going to say W minus 4 is 0, and also W plus 9 is 0. And then I'm going to solve it in my head. What kind of 4 and what kind of 9?
Positive 4, negative 9.
Positive 4 and negative 9. Because we've got to make these equal to 0, right? So negative 9 and positive 4. Okay, let's do some hard thinking. Can we have a negative width?
No.
No. Distances and lengths, you'll learn this more and more and more in geometry. Distances and lengths, they always have to be positive, okay? So we can't have the negative 9. It's very important that it gets written in your curly brackets because it's one of the values that satisfies this quadratic equation. So we have to write it. But then, given the constraints of the problem that we're solving for a width, we also have to cross it out because it does not work. Does that make sense? It makes the equation true, but it doesn't work in the problem. So we list it and then cross it out. Cool? Perfect. So our width is 4. Okay, does anybody remember how to find the length? 4 plus 5, we just add 5, which is? Woo, good recovery. 9 units. Now, it's really easy to check your work on these. Does anybody remember what the area was? Yeah, area is supposed to be 36. So it's really easy to make sure that 4 times 9, in fact, equals 36. Is this true? Okay, then it checks out. We did it right. Congratulations. Put your phone away. Okay. Questions about that one? Okay, this one is similar but slightly different. Excuse me. Okay, first of all, make sure that you're looking at the right room in the sketch, okay? Because you don't want to do all the work on the gymnasium only to find out you're supposed to be in the cafeteria. So we're looking at the cafeteria, okay? Kind of looks like a rectangle to me, right? What do we know about the area of a rectangle? Yeah, it's still length times width. So what does it say that the area is? Yeah, 1,800. Okay, now we've got our sides, our length and width labeled on our cafeteria for us this time. I'm going to make this one the length and this one the width, but really it doesn't matter. Because if I turn the picture sideways, like, you know what I mean? Doesn't matter. It's kind of arbitrary. So I'm going to plug in for my length that whole binomial, 5x plus 15. 5x plus 15. And my width is 5x minus 15. Now, if this 1,800 was a 0, all we would have to do is the ZPP, right? But it's not, so we can't. Sorry. So we need to get everything in standard form on one side of our equation. So how do we go from intercept form into standard form? Yeah, we got to distribute this out. So it's a little bit tedious, but if you do it right, some stuff should cancel, okay? So I'm going to do 5x times 5x.
25x.
That gives me 25x squared, good. 5x times negative 15, negative 75x. 15 times 5x. Anyone want to guess? Well, 5 times negative 15 was negative 75.
Positive.
Yeah, it's positive 75x. Okay, then 15 times negative 15. Anyone up on their 15 tables?
Isn't it 0?
No, because we're multiplying. It's negative, I think it's 225, if I remember correctly from the rest of the day. Okay, now I want a 0 over here. So if I subtract the 1800 from both sides, isn't it going to be negative on this side? So I'm going to move my negative 1800 over here also. Everybody still okay with that? Now I have a 0. So lots of stuff is about to happen. These two are going to cancel. Bye. And these two are going to combine. Now I have 0 equals 25x squared minus, oh geez.
2025.
Okay, thank you. You saved me. Okay, any thoughts? These numbers are awfully big. So whenever I'm seeing big numbers, I got to tell you something, guys. Mathematicians are as lazy as they are smart. So whenever the numbers are starting to get big, I'm like, there's got to be something I can divide out of here. You know what I mean? Because I don't want to work that hard. Is there anything that you can see that I can divide out? Yeah, 25. Let's try it. Let's see if we can divide both sides by 25. Ooh, that makes me happy. Why does that make me happy? What's special about 81? It's a perfect
Square.
All right, so that gives me x squared minus 81. Now, is this a binomial over here where I've got a GCF and I can factor and use my ZPP? Or am I going to try to go the square root method and get the x squared part alone? Square root method. Now you see why we did that at the very beginning, because now it's just obvious that's what you do, right? All right, so I'm going to pop the 81 over to both sides, like add 81, and I get 81 equals x squared. How do I undo squaring? Square root. Don't forget that there are two answers, a positive and a negative. So the positive square root of 81 is 9. What's the other one? This is not a trick.
Positive 9 and negative.
And negative 9. Andy, if that's what you were saying, it was so quiet I couldn't tell. Sorry, you might have been right. Or not, I can't tell. You've got a very good poker face right now. Okay, so last time we just got to kick out the negative 1 automatically because we couldn't have a negative length, right? X is not exactly the length or the width. X is just something on this problem that we can use to find the length or the width. So we have to see if it works if we plug it in. So you see this expression up here? We're going to check to see if the negative 9 works in here for a width. Test it. So I'm going to say 5 times negative 9, because that's my x, right? Minus 15. Does that give me a positive answer for my distance? No, it's huge negative number, right? So this doesn't work. So negative 9 doesn't work. Everybody happy with that? But on this one, I had to test it first. Okay, let's see what happens when we try the positive 9. So the length is 5 times our x plus 15. So I plug in my positive 9. 5 times 9 is 45. Oh, you're doing, okay, plus 15 is 60. And it says terms of feet, so I'm going to say 60 feet. All right, my width is 5 times my 9 minus my 15. And what did you say before? 30. 45 minus 15 is 30. Okay, do you remember the way to check? What do we have to do to them? We say, is 60 times 30 equal to the area that they gave us, which was 1,800? Is this true? Well, I know 6 times 3 is 18, so this is looking promising. Yeah, it works. Congratulations. Okay. Okay, on the back. So this time we're looking at the gymnasium. So we know that the area of the gymnasium is 1,200 square feet. So again, we know the area is length times width. So we're going to take our 1,200 for the area and set that equal to our length times our width. So that'll be 7x plus 5 times 7x minus 5. Okay, now I need everything in standard form set equal to 0. So I'm going to distribute. So I get 49x squared, and then 7x times negative 5 gives me negative 35x. 5 times 7x gives me positive 35x. And 5 times negative 5 is negative 25. Okay. Now I really want a 0 on this side of my equation over here. So I'm going to subtract away the 12,000. Sorry, that's 1,200. And subtract it over here also. Okay, now I have 0 on the left, and I have 49x squared. My negative 35x and my positive 35x, they cancel. And negative 25 and negative 1,200 gives me negative 1,225. Now, I really hope that I can divide out a 49, because that would make my life so much easier. So I'm going to try dividing this side by 49 and this side by 49. 0 equals, let's see. So 1,225 divided by 49, that's 25. Yes. Okay, so I get x squared minus 25. Now I can get my squared part alone and take the square root. So adding 25 to both sides gives me 25 equals x squared, square root, plus and minus. Okay, so I get two x's. I get a negative 5 and a positive 5 that make this equation true. When I think about plugging in a negative 5 into, say for example, this length, and I do 7 times negative 5 plus 5, oops. Okay, 7 times negative 5 is negative 35 plus 5, that's negative 30. I cannot have a length of negative 30. It does not work. Lengths must be positive and so must distances. So negative 5 doesn't work. I have to use the positive one and see if it works. Okay, so my length is 7 times my 5 plus 5 more. So 35 plus 5, that's 40 feet for the gymnasium length. My width is 7 times 5 minus 5. That gives me 30 feet. Okay, and here's my check. If I multiply 30 times my 40, do I get my 1200 that I'm supposed to have started with for my area? And you can see the 3 and 4, that gives me 12, 0, 0, that gives me 0, 0. Okay, so that does work. You can check it on your calculator. Checks out. So we did it correctly. All right, let's do the last one and then we'll be done. We'll go fast. Okay, we need a rectangle whose width is 5 units less than the length. So here's my rectangle. My long side is my L. And then my short side, instead of adding 5, I'm going to have to take away 5. So this is my length minus 5. So that's my picture. Check. The rectangle has an area of 24 square units. So we need an equation for the total area of the sandbox. That should be rectangle. You can think of it as a rectangular sandbox though, if you want. Okay, so I know that area equals length times width. And my area is 24, so 24 equals my length, L, times my width, L minus 5. I'm just substituting in. I'm putting in L minus 5 for the W. All right, now I can distribute my L because I have to, oh, I already did this. I wrote an equation. Now I have to solve for the width and the length. So I distribute my L and I get 24 equals L squared minus 5L. Subtracting away the 24 from both sides makes it negative over here. Okay, now I can see if I can factor my cute little equation to get binomials. So are there factors of negative 24 that sum to negative 5? 1 times 24, 2 times 12, 3 times 8. I'm liking 3 and 8. I'm going to go positive 3 and negative 8. Okay, so that gives me 0 equals my length plus 3 times my length minus 8. I'm ready for my ZPP. Okay, so I set each of my little equations equal to 0, L plus 3 equals 0, and L minus 8 equals 0. So if I'm doing this in my head, I can see that my L's are going to be a negative 3 and a positive 8. Okay, I know that my length cannot be a negative number, so I know that the length has to be an 8. Okay, so my length is 8 units. And my width is 8 minus 5, which is 3 units. Okay, here's your check. If I take 8 times 3, does that give me my 24 square units for my area? Yes, it does. So 8 times 3 equals 24. Check. That's our check. All right, that's it. Ta-da!